I wanted to take a brief moment to look at two-dimensional arrays and basically double pointers and kind of the relationship between pointers and arrays. In a piece of demonstration code, right now I've got this array that I'm going to initialize here and then fill in with various values. I have a double pointer, that's what the two stars mean, which is going to be an array that points to arrays of pointers. And then I fill that in here after initializing each of the individual arrays to be pointing to a single dimensional array. And then I go through and print out the original array. So this array parameter that I'm passing in here, I just print it out. And then the pointer, I do exactly the same thing where I pass that in. And these are basically identical other than the signature of them. So they have the same effect. Notice that with the two-dimensional array, I use bracket notation, which you're probably used to from Java. I also use exactly the same thing with pointers. It turns out that every time I use these square brackets with a pointer, that's a dereference. And secretly, that's what's going on with arrays as well. So this is the first dereference that gets rid of one of these stars. This is the second dereference, and actually gets at the original values inside. So let's take a look at how that actually runs. So I've got it running here. So when I very first start, we have this array that's created. If I start moving forward through it, I start filling in the value here. So notice that the array pointer is pointing to this array of pointers. And then the first time through, what I do is on this line right here, line 18, this creates a new actual single-dimensional array that it is pointing to. And then that gets filled in. And so when I jump back out here to the outer for loop, this array pointer here is going to create another one. And notice all this is happening on the heap because I had to use these new keywords here and then here on new. So when I actually fill these all in and get down to the print, it is actually printing this original array here. So here I am printing out the values. It's just walking through, printing out each of the things in the array, what we would typically think of after adding 100 to each. And then when we're done, we try printing out the two-dimensional array. And notice it's doing the same thing with exactly the same coding. So why would you do one versus the other? So what's going on here is when we're printing this array, we're actually passing this in by reference. So you notice we actually altered the original array when we were doing this printing, where we were changing the value. So in C++, it passes it in as a pointer to this thing. One thing to keep in mind is that you have to fill in, well, all but one of the dimensions. I could have just made this 3 by 3. That would have worked. But you're allowed to leave one of the dimensions out when you actually pass it in. So that does mean that you can't create a completely dynamic array where you don't know any of the values coming in. If you wanted to do something like that, you would have to pass in a two-dimensional pointer like this one, where I can create as many of these things as I want based on whatever I put in for this new keyword right here. So if I want to create a larger array, I can make this 3 here a variable, or I can make this 3 here a variable, whereas this is a lot more static. Either way, it has the same effect.